Now we can see how the quantum mechanical model explains some things. The chemical properties of elements are periodic because the number of valence electrons is periodic. Elements in the same column have similar properties because they have the same number of valence electrons. So here are some of those groups. This is the noble gases, right? Noble gases have 8 valence electrons. They're especially non-reactive. Turns out that atoms with 8 valence electrons are especially stable. Because when that level is full, then there's a lowering of the energy. They're very, very unreactive. The alkali metals are close to the noble gases, even though they seem like they're on the opposite side. But again, the periodic table really should be a circle, right? Not flat. It's like the Earth. And round things are hard to carry around, so we cut it in half and flattened it. So these guys all have 1 valence electron. So I think of the noble gases as being like, the in crowd in high school, right? Everybody knew who the in crowd was, but nobody is ever sure exactly how it was decided that those are the in crowd, right? But they all tend to kind of dress similarly, right? And so these are wanting to have electron configurations that look like the noble gases. Because the electrons are like your clothing, right? They're on the outside. The number of protons is your personality, your soul, who you are. You can't change that. But you can gain or lose electrons, right? So these guys, Mom made them wear a hat to school because, stocking cap, because it was cold. She's worried about them getting an ear infection or something. Moms can be so dumb. So they've got this 1 extra electron. If they could just ditch that 1 electron, then they would look like a noble gas. Would they become a noble gas? No, but they look like it. And for high school kids, a lot of times that's good enough, right? So these are very reactive, and so they will lose that NS1 electron to form positive 1 ions. And we learned in chapter 3, I think, that these guys all form positive 1 ions. Now we understand why. Because when they remove that 1 electron, that 1 valence electron, underneath is this full shell. They've got 8 valence electrons, and that's especially stable. The halogens on the other side of the noble gases. These guys are so close, but they're just short 1 electron, right? These all have 7. The noble gases have 8. So they just need that one thing, right? So they will tend to gain an electron because then they have the same electron configuration as a noble gas. 8 valence electrons is especially stable. So these guys all form negative 1 ions and gain 1 electron. So now we can see that the charge on the ion for those ions that are predictable will give us an electron configuration that's the same as the nearest noble gas. So the group 1A elements need to lose 1 electron to be like a noble gas. Group 2A needs to lose 2 electrons. Group 7A needs to gain 1. Group 6A needs to gain 2. Right? So all of those guys that we learned are predictable. Groups 1A, 2A, 3A, zinc, and silver. It's the 1A, 2A, 3A part. All are going to have a noble gas configuration. And this is a typo in the book because they're not showing hydrogen, and so they started numbering wrong. Started here. That's row 2, people. This is row 1. Okay. But see, all of these guys, when they gain 1 electron, they move over 1 in terms of electron configuration. Here, gain 2. This gains 3. People have asked me about carbon. What kind of an ion does carbon form? Carbon doesn't make an ion. It would have to gain 4 electrons or lose 4 electrons. And either way, that's just way too much work, right? So this is one of those people that's just happy being a loner and, I'm just going to be different. It's fine. Because, gaining 3 electrons is not necessarily an easy thing. we're losing 3 electrons. That's kind of a big deal. And these guys right here, 4 electrons, not going to happen. What about ions? So the anions that we see are going to gain enough electrons, like we were just talking about, to have 8 valence electrons. So if we look at a sulfur atom, this is the sulfur atom's electron configuration. It has 6 valence electrons, it's in group 6. And in order to have 8 valence electrons, it needs to gain 2 electrons. So the sulfide ion, S2 minus, has 8 valence electrons here. Because where do those 2 electrons go? They go into this unfilled 3p. This has the same electron configuration as argon. For cations, cations are formed when the metal atom loses its valence electrons. The process is always endothermic. These electrons don't just fall off. You have to pry them off. You have to put energy in to get them off. Here's magnesium. Magnesium has 2 valence electrons. 1s2, 2s2, 2p6, 3s2. So when you take those guys off, what's left underneath is this full shell of 8. Right? So I kind of think of this like, a little bit like peeling a layer off of an onion, right? Where the anions, you just wanted to fill it in a little more to complete the skin layer. And here it's like, well, there's just a little bit. Let's just take that layer off, and underneath it's perfect. So the magnesium ion is going to have the same electron configuration as neon. It's all about the 8 valence electrons.